In this session, we are going to discuss about K-map simplification of two variables. K-map simplification of two variables is a graphical method to solve the digital logic expressions. Apart from Boolean laws, here we are going to use the graphical method to solve the Boolean expressions. What is meant by K-map? K-map is a core map. It is a visual method to minimize the Boolean algebral expression without memorizing any algebraic theorems. In many circuits, digital circuits, we need to find out the expression with minimal variables. So in order to find out the minimal variables, we are using K-map. So it is a tool to simplify the Boolean expression. It helps to simplify logic into simple form by using truth tables. It also used to create minimal Boolean expression by identifying the patterns. There are two forms. First one is sum of product SOP and second one is POS product of sum. Now we are going to discuss about SOP sum of product. Next, grid setup and numbering. How we are going to form the grid size based on the number of variables. If it is a two variable Boolean expression means we are going to use 4 cells 2 cross 2. If it is a 3 variable means we are going to use 2 cross 4, that is 8 cells. If it is a 4 variable means we are going to use 4 cross 4, that is 16 cells. So based on the number of variables we are going to form the grid size. For plotting the values, for SOP, we are going to write the value as 1 in the min terms and 0 for the others. For product term sums, we are going to write the value 0 in the corresponding to the max terms and 1s for the others. So these are the steps to solve the expression using K-map. First step is we are going to select the K-map based on the number of variables. So first of all, we are going to identify the whether it is a min term or max term based on the problem. If it is a min term, you are going to solve for SOP by using ones in the corresponding blocks of the K-map respective to the min term. For POS, we are going to use the value as zeros in the K-map respective to the max terms. And you are going to form the rectangular groups like 2, 4, 8 as a power of 2. After forming the rectangular groups, we are going to form the SOP with the product terms. This one is the K-map in visual form. This is one of the example for K-map. So, as in the truth table, if it is 0, 0 means the min term is M0. If it is 0, 1 means the min term is M1. If it is 1, 0 means the min term is M2. If it is 1, 1 means the min term is M3. So, this is the graphical representation of a truth table by using K-map. For 0, 0, you are going to place the value M0. For 0, 1, we are going to place the value as M1 in the box. For 1, 0, we are going to place the value as M2. For 1, 1, we are going to place the value as M3. This is the graphical representation of a truth table. This is easy to group the minterms. Step by step example. First, you are going to form the truth table. So, in the truth table, for 0, 0, the value is 1. For 0, 1, the value is 1. For 1, 0, the value is 0. For 1, 1, the value is 1. This is the truth table for the given K-map. Now, you are going to draw the K-map. For 0, 0, the value is 1. So, you are going to put the value as 1 for the 0, 0. Then 0, 1, the value is 1. For 1, 0, the value is 0. For the min term M1, M3, the 1, 1, the value is 1. Next, you are going to fill the map. Here, The 0, 0, the value is 1. Already we have discussed in the previous slide. For 0, 0, the value is 1. Then 0, 1, 1. 1, 0 also 1. 1, 0 as 0. 1, 1 as 1. Next, you are going to group the values. So, first, we are going to form the pair by pairing the values, by mapping the values 1, 1. Then, you are going to form the another one pair by mapping the values as 1, 1. So, 1, 1, what is the common term? X1 bar. Here, for the green line, for the red line 1, 1, we are going to mapping the 1, 1 as a pair, and we are getting the value as X1 bar. And for the green line, we are mapping the value as 1, 1, and we are getting the value as X2. So finally, we are getting the value as X1 bar plus X2. In this table, the X1 bar is constant. In this table, the X1 is constant. So, another one example for K-map is for 0, 0, already we have discussed. For 0, 0, the mean term value is 0, M0. For 0, 1, M1. For 1, 0, M2. For 1, 1, M3. Next, we are putting the value as 1 for the min term M0. Next, we are putting the value as 1 for the min term M2. Then, we are going to grouping. So, M0 plus M2 is equal to M0 plus M2. Next, you are going to form the pair. So, finally, we are going to group the values as M0 plus M2, and we are getting the value as X2 bar. So, the common term is in the M0 and M2 is X2 bar. So, the final value is X2 bar. This is another one example for grouping. Then, what are rules for grouping? So, in two variables, we can able to group either a single variable or as a pair or as a quad. There are three things to grouping in two variables. Here, the grouping must be power of 2. 1 and then 2, 4, 8 or 16. Here, there is no diagonals must be grouped here. It is strictly prohibited for diagonals. We can able to group them as large as possible in order to reduce the number of variables. The overlapping also allowed here, and wrapping also allowed at the edges of the K-map. These are the rules for grouping. These are the valid groupings. We can able to group as a pair in the edges M0 and M1, and also M2 and M3, and then M0 and M3, M2, M1 and M3. This is also possible. We can able to group as a single variable. These things are not valid because they have grouped as a diagonals. Here the diagonals are strictly avoided in the grouping. Let's find out another one example. M0 plus M3. Here we are going to group the value as M0 plus M3. This is valid thing. Here we are going to form a value as x1 bar, x2 bar plus x1 plus x2. Thank you. Now we have discussed about the how the K-map is grouped in two variables. What are the methods for grouping? What are steps? Then what are the rules for grouping? Thank you for watching. Thank you.